Relax, Oasis, your moment of tranquility. Before we begin going on with the slides, we first review the goals, which is how to provide relaxed service, basically starting with the service catalog and the resource catalog, how to monitor and control the access, monitoring the sensors of brightness, temperature, humidity, and noise control, machine learning, also which all of them can be viewed on the Telegram and also a graphical plot visual by ThinkSpeak adapter, and in the end, the implementation of the whole project on Docker. First, we briefly review use case diagram. Let's start with the user awareness component. We have the Relax bot for Telegram, which keeps users informed about the system's status. And on to data collection and interface, ThinkSpeak is the platform that collects data from various sensors and provides a graphical interface for real-time data visualization. And also, ThinkSpeak adapter then adapts this data for integration with other system components. Now to communication and control. The message broker facilitates communication within different system components using the MQTT protocol. And at the heart of the system is the Raspberry Pi control unit. This unit manages communication between components, executes user commands, interacts with the machine learning model, and integrates various IoT devices. And in the post-process data analytics section, we have several control mechanisms, such as light, noise, temperature, humidity, and access control. Additionally, we have machine learning, which analyzes sensor data to predict safe occupancy level and ensures only authorized users are permitted. And also information through catalogs. The Relax catalog and users catalog handle information related to the relaxation environment, and user authentication using RESTful web services likely implemented using the CherryPy and Request Python libraries. The resource catalog registers and manages available IoT devices in the network. And finally, we have communication protocols in this project. REST Web Services involves providers which offer data or functionality and consumers which utilize these services. RESTful Web Services use synchronous communication and JSON files, and also MQTT communication, which involves publishers which send data to the message broker and subscribers which receive this data. MQTT is a lightweight publish subscribe messaging protocol. Our service catalog is a REST server and it is used as an entry point for all applications and devices to obtain information about the specific resource catalog in which they are interested. The resource catalog registers and provides a registry of all available devices and the resources that it exposes. When the resource catalog starts running, it must register itself into the service catalog so that all devices and applications can find it by passing through the service catalog. In this example, we can observe how temperature sensor that we have simulated contacts the service catalog to obtain the list of all available rooms that are resource catalogs. This allows the user to choose the room in which the sensor is installed to register itself into the registry of the service catalog. After these setup procedures, the sensor can start to publish its measurements. We can observe how the composition of the complete topic provides escapability by being composed of the institution-based topic, the owner, and the resource catalog topic that refers to a specific room. This automatically built topic provides escapability in this choice of which data to follow. In this case, the sensor is registered in a specific owner's room. In order to monitor the temperature and humidity and the brightness of a given room, initially we used a DHT1 sensor. However, we continued with a simulated sensor that constantly publishes the temperature, humidity, and brightness messages with a specific topic. It is possible to see in the terminal the registration phase of the sensor in a specific owner's room, then the payload published periodically by the sensor. We use a noise sensor that publishes messages with a given topic and sends the data related to the topic in the room via REST to a server that, depending on the message sent by the noise sensor, regulates the noise level. Moreover, we have an LCD where it shows the noise level. We can see how the sensor and the server register in the specific owner's room defined by the user. In order to control workers' access to a specific room, we use our microservice known as Sensor Evo that publishes messages and sends data to a server by communicating the approval or denial of the scanned physical code of a specific worker. To check if the user is allowed to enter the relax room, the physical code is compared with the ones present in the JSON file provided by the REST server. Once the REST server receives the information related to the approval or denial for the access of the user, another microservice called machine learning can manage the number of people allowed to enter the room using a machine learning model that considers the number of people inside, the temperature level, humidity. The Telegram bot aims to provide data related to the Relax Oasis. To do this, it sends GET requests to Raspberry Pi. It is a very helpful tool because it allows you to have a scalable service according to a hierarchical structure. The control officer can choose the room and the sensor with the relative plots and interesting values. The control officer can also control the data related to the temperature, humidity, and noise, and also light and brightness, and can act manually to the environment to make it more comfortable. For example, by asking people to avoid talking out loud. Let's see how it works. For example, we choose an operation, and first we choose Room Politecnico. As we see, all the sensors are available. And for instance, we choose humidity. It displays the data, and we can also check the plots on the ThinkSpeak. As we see, the ThinkSpeak data is displayed over here as well. Now, how about if we want to insert a new owner? It is required that we insert a password, which would be, as an example. And then it will ask us to insert the room, which we shall call it Valentino. And as simple as that, a new room is also created. ThinkSpeak is an IoT platform that uses channels to store data from apps to devices, or devices. The ThinkSpeak adapter is used to get the data from sensors via MQTT and upload channels on ThinkSpeak via REST using a POST request. We have used graphic to display real-time temperature, humidity, brightness, and noise values. A project has been implemented using Docker. Docker is a set of a platform as a service product that use operating system level virtualization to deliver software in packages called containers. Having containers and modifying the models and the scripts makes the whole project way easier for updates and fixing bugs and in general further optimization. Thank you for your time and attention.